All right, we'll go ahead. So our run's done. We're all feeling really good now, and Richard made all the plots, and I've taken it off of the multiple mode and gone to single mode, because at least for me, you can keep it there when you're playing with individuals, but I kind of like to hang out here. It's a good thing to know that this list will still show, so if you're in the single contingency page of this, right, that list is going to have all of them, which it won't tell you automatically, well, which one's violated, right? You're going to have 1,200 outages here. And again, you can make filters for that. So you can say, hey, give me everything that had violation field greater than 0, and that thing will shrink to just the ones that you want to look at. But when the tool's done, it tells us all the issues that we had with voltage. I ended up adding an extra plot, which is kind of important, the load bus voltage. Though doing this, that's pretty sporty. Yeah, we need to look at that. That more than likely. So remember the voltage, this is voltage, so you get your outage at 1, it clears. The big fields are 70%, right? And 80%, oh yeah, this is all over those. This is bad news numerous times that it's violated the WEC criteria for voltage response post contingency. So you have to fix that, right? There's a P1, which is this is not so good. However, there's a couple things that it didn't do for us. And again, damping is one thing that the modal analysis that's just going to be sweet. That'll be a little bit more, when you're responding to the TPL requirement that says, hey, R5 or 6, did you check for damping? And how did you do, what's your methodology for checking for damping? And then type in, well,
Matrix pencil.
I look at all the JPEGs, right? And wait a minute, I'm not on a JPEG. And you grab your coffee and you just go like this. And you, oh, that's bad. I'm looking at that. I'm looking at that. Right? Because what's the requirement on damping? When does positive damping have to be evidenced by? In time.
In the RC methodology, it just says positive damping. I don't know if
it says inside 30 seconds. So the TPL says it has to be 30 seconds. A lot of us test to 10, some to 20. And then you'll go in here and you'll figure out, okay, I got to run this one out, or I got to investigate. That just doesn't look like a whole lot of damping going on, right? And it seems so draconian, but honestly, I'm glad to hear there's more than one of us that does this, that just goes through the JPEGs and enjoys coffee. So that's how I check for damping. Yeah, I've seen it in like other interconnects. Now that I'm having exposure to those, PGM does it by calculation, so they use those. PGM does it by calculation, so they use a field and they calculate some formula for looking at maximums and minimums, and they say if this thing looks like it's going down, it's positive damping, we'll call it a day. So they have a very programmatic way to do it. Some kind of programmatic way to do it.
Richard, one tip on a plot like that, you're plotting megawatts, right?
Yeah.
It's very easy to make a plot that plots the deviation from the initial megawatt. So then you don't kind of hide stuff down in the maze of signals at the bottom.
Yeah, the plotting in here, again, you can plot expressions. So when you're plotting like relay performance, disk relay, you could plot the Mohs circle, and you can put R and X, and it's kind of cool looking. If you need to impress somebody, like Lucas, but he already probably knows that. But relay performance, how did we check for power swings? Well, we didn't, right? So we got a hole here, at least I think. And some of the assessments I've seen, again, for this requirement, I've seen it say that we assume no relays are going to trip for power swings. I just go, good luck with that. Now, I think Power World gives us a fair approach to that standard with disk relay. So let's install disk relay and run this again, and I'll show you how that works, because these things are actually quite good. They operate off impedance. If your line impedance, you and protection are a one mine on the line impedance between breaker to breaker, this thing works really well. So how do you do disk relay? Let's go back to our, oh, look at that. That's a lovely thing. Here we are in our case, just minding our business. Up here in stability case info, if you click on that, you get down here that says insert transient stability data. Hey, look at that, auto insert disk relay models. We're going to click on that. We get a dialog, auto insert disk relay models. we're going to click on that. We get a dialog that says, hey, what's your zone 1? And I'm just going to use 80. 80%. Is your zone 1 80 or 90? What's your zone 1? Zone A, some people call it zone 1. It's going to add one at both ends so that, you know, each is looking, using the same. And these are segment impedances, right? What you have to do afterwards, this will put a disk relay pair on every segment between a breaker. So you can, if you want to, once your assessment's done, it's January 1st and all the dust is settled, you can go back in there and delete all those internal ones and just have at the breaker here with the right impedance. Transfer trip works, we're going to turn that off. You can have it like the little Mohs circle there. There's a lot of opportunity here. We're just going to say insert. And it's pretty unexciting, right? We just did it in use, and there will hopefully be a whole bunch of disk relays that showed up. So now we have zone distance relays on all our segments. So let's run our outages again and see what happens. And we're only going to run the small set because they're ready to go. These things are ready to go, sort of. Everybody got that so far? So let's control tab back to this land here. I want to go multiples again. So I'm going down to select multiples because I want to run my 7 or whatever it is that I still have left. And, you know, we got this kind of violation so far. Anyone know what's going to happen?
Quick question. So you didn't filter, when you added the distance relays, you didn't filter by your 500 kV lines. You added it to the entire.
I threw on the whole thing. Everything's got it. So yeah, you can again, like power, you can filter anything. You can just put them on Bonneville's 5. Did this 2 years ago, right? They did a PRC 26. They took a swing at it. And I think Avista and Bonneville were the only two that submitted relay sort of information for that, and they auto-inserted for the rest of Area 40. Because the standard just says generic relay model, and I think fairly this is a good approach to generic relay models. What's so exciting, this case swings. So, Jamie and Tom, you might correct me, but for some of those big honking outages in this 2,000 bus case, we actually get a swing that gets relays in the game. I was totally excited when I saw that.
What does it do? It swings?
The power swing was enough to trip relays over here.
Power swings are enough that it looks like there's a fault.
Looks like a fault. We're done. We're getting close to. Oh, we're kind of slow. So we'll just wait. So we look right now. There's 6 lines. Some of those cleared. Did you notice that? Looks like a fault. We're done. We're getting close to. Oh, we're kind of slow. So we'll just wait. So we look right now. There's 6 lines. Some of those cleared. Did you notice that? So the bummer is these are all going to clear. All of them. And I'll just go through the problem with that as it's running. The issue is how, it's not bad. You have to default it somewhere. When you auto-insert something, Jamie and crew have made it automated for us. And we just need to be aware of, well, what got automated? And what got automated was the time that these things play. So if we go back to our, I'll just leave it running, but go back up here. I think I still have, do I have that open? Yeah, which will get to this screen, disk relay. Right click on the disk relay thing and open the dialog, show dialog. And it'll open this big honking window, and we are going to scroll matter to us, well, at least right now. So these are the settings that matter. No trip. If this is a 0, they're going to trip. If it's a 1, they're going to tell you they would have tripped. And the problem with ours right now is, here's the shape, that's a circle. This guy. Direct trip is at 0 cycles, millisecond. So right now the relay sees it and it opens, which is not what happened. That's not what happens in reality, right? Protection sees it and a couple cycles go by and it opens. That's how we've defined it, right? I think these are all defined as 5-cycle clears. So what's happening with the default settings in disk relay, they are really aggressive, right? They're clearing at fault time, which means we really no longer have a transient. Transient happens, relay clears instantaneously. So you do have to go back into here and fix this. And what we'll do, I will just pause. Transient happens, relay clears instantaneously. So you do have to go back into here and fix this. And what we'll do, I will just pause the game here on this. I want that. I just pause the game big time. I'm going to go back to transient. Come on, wake up. Hey. Uh-oh. Things are frozen. What'd I do? Will that float over that, Jamie, and kill me? Maybe it does. Let's try that.
Hey, teammate.
We're gonna go look at our skip, no skip. I think some of these, so these should all be bad. Let's go to this guy right here. Oops. Oh no, I'm in trouble.
We're not laughing at you.
That's okay, it's worthy. I need to find my, let me go single here. Let me find my, what is that, Glen Rose? Who's that guy?
There's a fine spot in there too.
Glen Rose to Stephenville. This is a rowdy one. We're just gonna run this guy. So right now I'm in results from RAM. This is a handy place to go in events. And I'll spend a lot of time here watching this stuff happen. So results from RAM, events, what I want from RAM, events, what I want to see is dist relay show up. There we go. So time, right? 1 second. Here is fault time. And unfortunately dist relay saw it and opened. So it even opened 5 cycles before my definition told it to open, right? If I go back to my definition, I said, my protection folks tell me this stuff opens in 5, so that's what I have to manually tell it to open in 5. The cool thing about dist relay is if you tell it the thing operates in 5, I can get rid of these definitions because it will open. And you'll see each end get in the game. The trouble with the current one is, again, we had it, I didn't do that. Oh, it's going to plot. That's bad. So I'm going back to events. There's our whole thing. Again, time 0. This really came in and punted everybody. 5 cycles later, these are already open. Device is already open. So we just need to open. Device is already open. So we just need to change our dist relay settings. Make sense? So let's either put this at 5. What we're going to do is actually put in just watch only. And then we'll be done. Dist relay dialog. We'll do that whole, where we got direct trip. So we're going to say set toggle column. So I'm going to go over there to that thing, direct trip time, set all values, and we're just going to make it 5. Actually, oh, I'm sorry. We're going to skip it. We're going to go to no trip, right click, set toggle, all values to 1, which is a flag for just tell me what you were going to do and just log the error and don't trip. And then we should see lots of excitement again. So watch up here, we get started. So watch up here, we get started. There we go, so it's not, it's gonna wait. And I think this one really gets exciting in a bit. Yeah, look at that. Relay's happening alone. This is totally exciting, and they're way away from that initial outage. So this case will swing. And other relays that aren't near that one on the line that are supposed to function, which they do, right? Direct trip here, Glen Rose, Stephen, that's where the fault is. But you got Odessa and Midland, so that on our map, Stephenville to Glen Rose is, oh, come on, don't plot again. Come on, be done. Come on, laptop.
a little harder.
Another reason he's not saying
Standard user.
Okay. Good grief, stop drawing.
Doesn't run settings. You broke too many computers.
In my map, my fault is here, and those other ones are happening way over here. Those other relays are playing, and it's a power swing. By their definition, this is a power swing that's causing those disk relays to function, which is so cool. I mean, for me, I wanted a case that actually had a swing, not a fault, that would cause these relays to function. Do you get my excitement? I'm totally excited. This is awesome. Look at all those guys playing. So for example, if we just sort on, if I right-click on this relay, and I do, what do?
Control Q.
Control Q?
Yeah.
Ever?
Since sliced bread.
Those guys are mad right now.
There's tons of relays in the game here. And again, this is a big east-west path on this particular case, and we faulted that line and then popped it open. And scads of unrelated disk relays would have played. That's what that's telling me, which is kind of cool.
Is that because they didn't set the relays right, or is that because you couldn't build them?
Well, so I believe this is a swing. So in a WEC case, I didn't know in certain scenarios a triple palette might do it. And so what I did, I put disk relays on. I went to the breakers and made sure the definition, and I hung a big monster cheap Joe-ish break off of a bus, and all I did was energize it at 1 second, just to see if it could get a big enough swing nearby, and it did. So I knew first my relays were working correctly, because they do. If you move this out of zone 1 into the middle, the two zone 1s play. If you move it out of this one, zone 1 and zone 2, I knew first my relays were working correctly, because they do. If you move this out of zone 1 into the middle, the two zone 1s play. If you move it out of this one, zone 1 and zone 2 play. So they function off of impedance. They're actually done quite well. Correct me if I'm wrong. And then my big cheap Joe break thing, it was 8 gigawatt load, and at 1 second I energized it, and relays, I don't know, 8 buses away, there's a group over here that all play it. And that's a swing for them, not a fault. So that, in my methodology, I said, well, as far as I can tell, I've sort of validated that these relays will both function for actual faults and swings. And that's what I have today, right? For that compliance standard, that's not bad. And I think it's literal enough that says, yes, we've done what we can with the software we have to comply with this standard. I say to our protection folks, PRC 26, during the annual assessment, relays played, which they didn't.
And is there a corrective action that's required, or you
Say, hey, guess what? We got issues. Here's all the relays that played.
Yeah.
Do your protection magic and make that happen.
Or make that not happen.
Make that not do that.
Yeah.
Because I know a lot of folks set them to 150%, right? They'll look at some of the load impedance that sits out over here instead of line impedance.
Yeah.
They'll have a number they set it to. But we can now actually show something in simulation where they played. Those guys actually wanted to play, which that's probably cascading. If I turn them all on and yet turn this one off, don't let this first one play, but don't the other ones play, we may have a big come apart.
And then your SPC guy tells you your settings are wrong, and you go and change them. And
Is that what happens? You'll brawl?
Well, no, you just go. Your settings are wrong, and you go play them back in, and then you realize they're right.
So is there different kinds of relay? Because that's just a distance relay. It's not that big oak circle, and they can narrow that down so that they're loaded. So is there different kinds of relay? Because that's just a distance relay. It's not that big oak circle, and they can narrow that down so that the load encroachment isn't as big of a problem.
There's different transfer trips, there's blocking on here. It's a pretty well done distance relay. There's other relays, the stuff that we've all used, like the T-LIN stuff, and there's relays for generation, voltage, and frequency right through, those kinds of things. But from my understanding, Jamie, this is the best one for me to use to get TPL1 and PRC 26 at least closest that I can get that I've ever seen.
And then at least you go and you look at it and say, well, was it a real trip or was it just a...
Yeah. And they're surprisingly accurate because it's the same impedance that our protection folks are using. That's the same one. Now the difference would be if you're not using the same impedance on the line, and which is possible.
Or if you have some other blocking.
And
system.
if this becomes, hang on a second, there was a project that Kate did with the Vista it was specific to a relay. That at Power World, read the settings off that relay to set these up. Then it's even better. Yeah, here.
I remember what putting in like a Z line.
Yeah.
Is that just, that's the generic one though, where you just do a pure 20-80%?
Yeah, you'll see those,
It's a Z-Lin W.
Z-Lin, yep.
Applies to everything. It's in power.
But this one is one, if you want to apply everything, this is one if you know your relay settings, and you want to put every line relay setting.
In some cases in WEC, these guys, Z-Lin 1 are set to default be in the game. They won't be set to trip, but when you look at the event relay, they're playing as well. And I typically delete those, because now that I have this relay, I just understand it better. But it's a really good way to comply with that part of the standard. It still seems a bit ahead of the game, really it does. For what the PRC asks for, protection folks assuming, we just get it from the annual assessment where they've done all this stuff with the relay model. And we're over there going, when that came out, we didn't have any of that. What do you mean? When that came out, we didn't have any of that. What do you mean? We modeled generic relays. They were there, but they weren't as sexy as this relay.
I assume it also accounts for series caps being bypassed or service.
What's that?
I assume the impedance is being accounted for with the series caps.
It's interesting. They're all on this relay.
Probably by
They might
branch.
do it on the one side of the series. I don't know how that works. I should look at that. If there's a series cap, which side does it put it on both sides? If it's a line, because that's a cap.
It's only looking at the voltage and current there, so there are other models that could bypass the series cap during the fault, the SC gap. But I mean, there's a lot of work if you really want to model exactly what's going on. There are models to do it. but you have
There
to-
really are. We've even played with the disc drill with a 3-terminal line. I started pondering and playing with something like that because they're out there, right? 3-terminal lines are out there, and it is still an impedance. Protection system's looking for that impedance and is making some assumption on which left or right. And well, it's based on impedance, so you can play with something like that. You have to manually do it, but you can still do it.
He was asking about load encroachment. There's a special model called RELODEN for relay load encroachment. And that disables the impedance reading if they're in a particular region.
That's all I got. That's planned for today. Any questions on the case study issue? We won't go into correction maximum time. I don't want to solve that one that's banging all over the place. That 5-cycle clear, you might 3-cycle clear it and that might go away. I haven't played with that yet. 5 cycles kind of slow. Well, you can buy into 3 and 4, right? To hopefully clear some of that stuff. So again, most of that's fault clearing, but that's an interesting. There's enough issues in this 2,000 bus case that you can do a lot of luck. So again, most of that's fault clearing, but that's an interesting. There's enough issues in this 2,000 bus case that you can do a lot of learning and still get results pretty quickly, and you can't hurt anything. Cool. Awesome, thank you.